Hey guys, welcome back to the shop. We have some relatively simple lathe work that we need to do on these three pieces of tubing. We need to set these guys up, face them off to 4 3/8 long, and we need to bore the ID to match the sample right here. And then after that, we need to actually broach a keyway. So this is a metric bore and a metric keyway that we're going to be putting inside these pieces of tubing. And what they are, they're going to be custom dies or custom die rollers for a rolling machine. Doing this for my buddy Joe down in the welding shop. He's got some rectangular tubing that he wants to roll, and that's what's going to help him get it done, is these guys right here. So I know that he said what he plans on doing, because he needed like the full length of this right here to get it to fit in there, but he is going to cut some thin washers on his plasma table to butt up against the face of this to kind of serve as a shoulder, and then he'll put the nut on there. All right, and I know that he said he's rolling some thin wall aluminum tubing, so there's not a lot of pressure that's going to be applied to this. But there's nobody else in town that actually has a machine capable of rolling this size tubing for whatever reason, so he's going to make his own. All right, so this is one of the spacers that come off of that roller that he's got, and I believe, if I remember correctly, it was a 40 millimeter ID. I'm sorry, 50 millimeter ID. Okay, so 50 mil ID, and then we've got a 14 millimeter keyway to broach inside there. And then what we're working with here is some 3-inch OD by 1.5 ID tubing, and he has got them cut 4.5 inches long. We're going to actually face them off and finish them at 4 3/8. All right, so we'll go to our Victor lathe, get the lathe work done, and then I need to see if I've got a broach bushing, I call it a broach plug, and a 14 millimeter broach to get that ID cut. So let's go check the cabinet, make sure I got the tooling for this before we get going. All right, so my broach tooling, most of it anyway, I keep back here in this cabinet. And let's see, I believe it's this guy right here. Yep, so there's some of my broaches and broach plugs. Let's see here. That's a 65. I think it's this guy right there. 50 millimeter. All right, so we got the broach plug. I don't know if you can see it on camera right there. Dumont 50 millimeter /D. All right, so that's the plug we need right there. And then we need a 14 millimeter D-sized broach, and that's going to be this guy right there, 14 millimeter D. So there we go. We actually have the tooling that we need to get this job done. All right, so we got our broach bushing that will fit the bore like this. All right. And then what I like to do, this is something that I done a long time ago, just drill a hole and install some kind of pin. This is just a split pin right there, roll pin. And then that keeps it from falling all the way through there if it does slip all the way. And then you have your keyway broach here, a push broach. And you're going to have your shims. And you stick this guy in there like so, and use your press and press it through there, so you'll make a pass with that guy. And then we have a couple of shims to put behind it to progressively get up to our depth that we need there. All right, so like I said, relatively simple stuff, but a job that we got to get knocked out for Joe, so let's go ahead and get started on it. All right, we're over on the Victor lathe. First thing we'll do, let's just get one of these ends faced off here. I'm going to go ahead and measure it just to kind of see where we're at. Yeah, that's 4 9/16 right there. He wants them finished 4 3/8. So let's get a good clean cut across them first, and then we're going to put a stop in here in the chuck so that we can accurately push against the face and get them all the same length once we have a length established on them. I was chucking up that label that was on here. All right, here we go. We'll use our magnetic back indicator right here. This is another tool made by Ed's Technology Products. Works really well. Just getting the chips off of it here. You can put this on your V-ways here for your lathe, and it squares up nicely nice and parallel to the ways here, and you got a dial indicator you can use. All right, we'll run about 600 RPM, fast feed, something like that. Let's take about 50 thou off of the face. Bring this up to 0, 50 thousandths. All right, let's just go ahead and do that to all three of them so that we get a good face established that we can push up against our stop. So we'll pull this guy out. Not worried about them burrs right now because we're going to be turning and boring these guys. And let me just go ahead and verify the length before we face them with the calipers here. Yep, over 4.5. Get it touched off, and 50 thou. You don't have to zero that indicator. All right, we'll get this guy out. Let's go ahead and set up our chuck stop now. All right, so we're going to use our chuck stop. This is another tool that's made by Edge Technology Products. Comes with these spiders that we call. You got your spacer that bolts on there that has to be kind of turned or filed to fit the bore of your chuck. They got the 3 magnets on there, and it comes with a set of different height parallels that you can put on there to set different end heights or stick outs from the face of the chuck. But all we're doing, I usually use the shortest one for a lot of this kind of stuff because all I want is just a face for the tube or their workpiece to push against every time, and it locate it to the right length. So all we're doing is making a face to push the tubes against here. All right, and so it pulls it up against the face of the chuck there. Now you push it up against those parallels there, and what I'll do, I'm going to take our piece of tubing here, and I'm just going to kind of get a quick measurement on there. 445, we're going to be taking this to 375, so I know we got about 75 thou to take off that. So we'll go ahead and just push it against the stop, tighten her up, let's make a cut, and we'll measure this one. Once we get this one faced to the right length, we'll have a 0 set on our dial indicator here that we can bring the tool up to for the remaining 2 workpieces. So just going to touch that off. Let's bring this indicator up. I'm just going to take 40. And then we'll pull it out and measure it. Just leave the tool right where it's at. We'll go ahead and remove it. I like finding my pinion that has the 0 stamped on it, so that's why I usually rotate it around. So let's pull our part out. And this is nothing super critical. This is, you know, you get it close and it's going to be good enough. All right, 406. So I'm going to take, let's take 30 thousandths off of this one right here, and then that should create our 0 position for our dial indicator. Put that back in there, tighten her up, and I'm going to dial in 10, 20, 30 thousandths right there. And I'm going to reset this. And we're going to just create a new 0. And that should create our 4 3/8 end length right there. Back off the face just a little bit so I don't scratch it. Not that it really matters, but pride in workmanship. Back to our 0. And then we'll take it out and let's do a measurement on here and see where we ended up on our face length. We were looking for 4.375. And let's see what we got. 4-inch 378. So 3/1000ths over that. Like I said, not a big deal at all. 378. So we'll just go ahead and face the other two to that same length there. Now I'm not going to be taking all this in one pass, so I'm just going to kind of bring the tool up. We know where our 0 is going to be, where we'll finish it at. But that would be too heavy a cut on this lathe here, so I'm going to back off. Just eyeball it about halfway maybe. This lathe seems to work pretty good with about a 1/16 face cut, so about 60/1000ths. You can take more depending on the job, on the material, but my go-to for quickly facing is typically 50 to 60/1000ths a pass. Now I'm going to bring the tool up to our 0. You're right on the borderline of being too deep on that face. It'll start chattering on you on this lathe if it's cutting too heavy on the face there. All right, let's see if we matched up to our length on this one here. Let's see how close we got it. Oh, look at that. 375 on that guy right there. That one's right where we wanted it to begin with. No big deal. Just do the same thing. Push on it, snug it, tighten it, and face it off. Seeing where we're at. So that's our total. You can see that's how much we got to face off that guy. I don't want to take that much. Just trying to take about half of it. Right on the border of being too heavy. We got her though. There we go. We're going to go ahead and remove this stop now. We don't need it in there anymore. If you guys are hearing that rooster in the background of the videos, I just want you to know that's not my rooster. That belongs to the next door neighbors. Why they feel the need to have a rooster over there, I don't know. All right, let's go back in with one of our work pieces. And now we'll go ahead and get our 50mm bore taken care of. I'm just going to go ahead and push it all the way back against the face of the chuck there, because that'll help block the chips from slinging out at me while we're boring it. I've been trying to find my 1-inch insert bar. It takes carbide insert, but I think I took it to the new shop to use on the Precision Matthews lathe. So all I can find is my bars that take a tool bit here. So I believe we're going to use this 1.25" boring bar. I'm going to take this tool that I have turned for right and left hand turning. I'm just going to cut it in half, and we're going to use that high-speed steel tool bit in there. I've got a chip breaker ground on that, and all I need to do is just give it some relief on the bottom so it doesn't rub the bore, and we'll just use our high-speed steel to come through here and cut that. We'll have to use a little bit of cutting oil on it, but this is kind of going back to a lot of the machining that I've done over the years, me and my dad both, where you have a lot of high-speed steel tool bits that you grind up to do the cutting that you need. So I'll just take a cutting wheel, cut that in half, do the bottom, and we'll get started on this bore here. I'll use my Metabo and cut off disc here to cut our tool. And this piece goes back in the toolbox, but I like to dress those ends on the grinder so they're not sharp. This is our boring bar tool right here. I just want to get rid of those sharp edges. And I need a little bit of relief under the bottom cutting edge. We'll use the coarse wheel here. Something about like that. All right, the edge looks really good. The last time that I used it, we'll just hone it. And then that's the other half of the tool that we're gonna put back in our drawer. Just breaking that sharp edge off the edge. Good to go. This is one of my drawers I have used for, I don't know, 25 years or more. All tool bits that I have used. Other people have used, other people ground them. I've ground many of them, but they go in this drawer. Just trying to find the right one. So that can be used for right-handed turning right there. It goes in the drawer. I got all kind of tool bits that we've hand ground for cutting grooves. There's a wide groove tool right there. Just all kind of stuff. We got carbide or brazed on carbide in there. Little boring bars. Just all custom ground tools as needed for different jobs. And they just kind of go in this one spot. This is sort of my go-to drawer for my particularly 3/8 square tool bits, because that was the most common size that I liked to use in our boring bar holders and our Armstrong turning tool holders that we use as well. Take our tool bit, get it stalled in the bar. It's probably going to have to stick in there pretty close. I think we'll try that right there. All right, let's see if we can see how this reacts. See how our tool does. Let's try 100 thousandths and see what that does. Now I'm going to be using cutting oil for this. If anybody questions why I'm using cutting oil versus coolant, it's because this lathe is not equipped for flood coolant. So we're going to use old school dark cutting oil in there. And see if we can get it to break a chip. It looks like it's rubbing. Let me see. It's breaking a chip. All right, we're just going to let it roll. No, we're not. It seems to be rubbing a little too much. That first pass isn't too pretty just because there's not a lot of clearance in there between the workpiece and the boring bar, so the chips are kind of rolling around there and pushing the bar away. So that's what you're seeing. The whole, it's just kind of shifting everything, but as we get it opened up, it's going to create some more clearance and it'll stop doing that. All right, we reached the back side. I'm just putting a 0 just to gauge where we're going to be at. We can drag it back through there. But you can see our tool's working pretty good. We're making little curlicue chips, which is what you want to do. You never want to make stringy chips coming out of there like, you know, if you're drilling a hole. But let's just go ahead and let me see if I can get us a little more clearance. I think we might be able to get a little more clearance out of it. I like using the largest boring bar that I can fit in the hole. You get a little more rigidity and less pushback on the bar itself. And these bars work really good. These are the Aloris boring bars, and this one is the 1.25 inch. Cutting oil, that's what helps to Shop smells so good in here. And I'll just touch off again. Just take another 100 thou. It's looking pretty good right about there. Let's get a check on our bore size. 1 inch, 655. We're going to be taking this to 50 millimeter, 1.968, 969, somewhere around there. So we've got another 300 thousandths to come out of this guy. And our tool bit, our high-speed steel tool bit is working great. I got the grind working good on that. Our chip breaker grind. Let's go ahead and just take another 100 thou. That's my go-to pass is 100 or 125 thou. One of the reasons why I like keeping it 100 thousandths or 200 thousandths is just because of the dial here on this lathe. Reads 400 thousandths per revolution, and so if you're taking 125, it's just a little more difficult to keep up with it, because then you're going 125, 250, 375. To me, it's easier to go 1, 2, 3, 4, 1, 2, 3, 4. Let's go ahead and I want to measure the bore of this. We're just going to match the bore of this factory-made piece because we know it fits on there really well. Just use our telescoping gauge and a micrometer. Come in here and get an accurate reading on our bore. We know it's 50 mil, but I want to know to the thousandths what we're going to be needing to make this to. So looks like it's 970, 1.970, which makes sense. So they give it looks to me like they're giving it approximately 1,000ths clearance. I did not mic the shaft that this goes on, but I'm assuming the shaft is made to 50 millimeter. So that'll give it about 1,000ths clearance if we make it 1.970. So one of the things I've grown accustomed to doing is when I have a size I know I want to hit, I love these little post-it note pads right here. These are the extreme ones, really nice and durable. I just go ahead and write my target dimension on there. So we're going to go 1.970. That's going to be my target. I'm going to take that to the machine and be able to look at it. I'm not worried about a plus or minus tolerance because I know what I want to hit. I don't want to take it underneath this, but I really don't want to go over that. But if we're over to another thousandths or two, it's not going to hurt by any means. But this is the target that we want to hit. And then that way I don't have to continue measuring it because I forgot what I measured it when we mic'd it. So we're down to our last 100 thousandths, maybe 120 thousandths or so. I think what we're going to try to do here, let's see if we can split that into 2 equal cuts and land on our target size of 1.970. So we're going to get a measurement on here. I'm just doing this to kind of remove any of the fine chips inside that stuck to it that might interfere with my measurement. And we'll use our telescope gauge, rock it in there in the back, get it centered up, and then pivot on the bottom leg and just push it with your thumb until it reaches top dead center and it falls out. That's going to be the exact diameter that the bore is. And let's go ahead and measure this. That's 855. So that's what, 115 thousandths? 50, 55, so 65, 7, that'd be 15 plus 100. 115. All right. So how about we take 60 thousandths. I just want to kind of split it in half. So what we're going to do is take 60 thousandths. Let's see, 10, 20, 30, 40, 50, 60. All right, let's take 60 thousandths. And we'll make this pass through there. What you want to try to do is equalize your pass, okay? So if you're going to take a really light finish pass, then you need to make a light finish pass before you make your actual finish pass so that you have equal tool pressure. So this will about equalize it. Let's see how it does on a 60 thou cut. It looks like it's going to break the chips nicely on that one as well. The battery's about to die on the camera. We'll get this swapped out and I'll bring you guys back when we go to measure it for our final cut. All right, we finished that cut. One note to make is that I didn't move my cross slide at all. We just brought it back through there, blew it out really good. The finish feels really nice in there. Whenever you have a good edge on your high-speed steel tool bit, if you had a good edge on there, it'll leave a nice smooth finish. Now it's going to look, you see the tool marks more prominently than if you're using a carbide insert, and that's, people are so used to a carbide insert finish these days. Most people, when they see something like this, they might consider it raggedy or ugly or they didn't do a good job, but believe me, this is more than suitable for this part that we're making right here. So we're going to go ahead and measure it and see what we got left to take here. I'm measuring 9/15. So it should be 55 thousandths, right? It should be 55, but what I'm going to do, I want to go ahead and double check myself. Usually when I get to my finish here, I will do this 2 or 3 times and just compare my readings because they should be similar every time I mic it here. Even though you can, that's easy math to do in your head, but it's also an easy one to screw up on. So I like to just use my calculator. I'm going to go 0.970 minus 0.915 is 55. I'm just verifying that I'm adding that up in my mind correctly there. All right. So let's see what we can do. We're going to go ahead and put some more cutting oil in there. That creates a better finish in there that helps lubricate those chips from trying to chip weld and gall as it's cutting. So I'm going to go ahead and dial this in. 10, 20, 30, 40, 50, and 5. And let's see if we landed on our target. So as I said, that dimension isn't really critical. The main thing is that we don't need it to be undersized because we want the roller to slide on that shaft. But realistically, you could bore this thing 5 thousandths oversized. It's not going to matter. These are going to be slipped on that shaft. It's going to be tightened up with a nut, and it's a very slow moving roller for that rolling machine. All right, that's the end of our finished cut. Now I'm going to take the cross slide and push it back so we don't drag with our tool. And let's see if we hit our finished cut. See those little curly Q chips? That is exactly what you want when you're using a high-speed tool. If you grind a chip breaker on there properly, you can get that. Then you're not fighting stringy, long chips. All right, and it is a little warm, so we do have to, be concerned about shrinkage here, that we don't shrink underneath our finish. So I'll put a little fan on it here in a minute, cool it down, and then check it again before I take it out, just to make sure. That's one of the benefits of running flood coolant, is that you can cool something down or keep it cool while you're cutting it. All right, so it looks like I got 969 is what I got. So technically we landed on our size that we want, 50 mil. I'm looking at my chart. 1.9685 is your inch equivalent. Let's go ahead and measure it again. May have to go through there and just let it skim, a thou out of it. Yeah, it's 969. So 1 thousandths off. What I'm going to do, I'm going to cool this down slightly. I'm going to measure it again and make sure that this is not, it doesn't shrink under that. I think if we leave it right where it's at and it doesn't shrink, it's going to be fine right where it is. Cooling it down. Just put it in low gear, put a fan on it. It won't take but just a couple minutes to cool that guy down. 968.5 I'm getting about a 1/2 thousandths difference. I think I'd feel better if I actually run the tool through there again and just try to take, you know, another thousandths out of that, just to ensure that we're going to have a proper slip fit on the shaft. Looks like we're cutting now. I'm going to go ahead and put some cutting oil in there. That should take at least a thou out of it. All right, just made our pass there. You can see, hopefully that's going to be our thousandths or thousandths and a half that we took out. All right, did we do it? We did it. There's 970. I'm getting 970 and a half right there. So that's exactly what we got. Took about a thousandths and a half out of it. I'm coming over here to grab the broach plug. We'll make sure that it slides in there. Cleaned it out really good with some solvent and degreaser and blew it out. Got them chips out of there. Now we got the proper fit there. It was just binding up on some of the real fine, tiny chips in the bore. All right, first one done on the bore anyway. So we'll go ahead and remove this guy. I'm gonna do the same exact thing for our other two. Not gonna show a whole bunch of video of that since we just did this. We'll get in there kind of tight, show you some chip making action with our high-speed tool. But when we get those bores done, we'll set these guys up. Probably go ahead and do a chamfer on the ID here, and then we're going to set these up on probably an expanding mandrel and just skin that OD nice and true and round to the ID, okay? I just finished boring the third one there. Here's a little bit better look at the finish that high-speed tool bit makes in there. So let's go ahead and check our fit with the broach plug. There we go. We got her. I'm going to break the edge, the inside edge on all those right there. We're just going to use that insert tool. That way it'll leave a nice finish. All I do is once I get the tool in there, I loosen this up and I just pick this up some like that so that it clears the bottom of the tool. It doesn't rub. As long as you don't go in there too far, that'll work just fine right there. Oh yeah. Getting slung with cutting oil there. Just want to bump it in and out quickly so you don't rub the tool. You can feel it. It did not roll or rub an edge on there. So that's going to be good. Now this is where there's going to be a big mess here. We need to clean up a little bit. You can see the back side of it. I'm going to go ahead and knock some of these chips out using our air. Go back in there, finish chamfering them. I'm not worried about the outside because we're getting ready to set that up on a mandrel and turn them down. All right, that takes care of all the chamfers. So I'm gonna go ahead and I wanna wash the bore out, get rid of any of the cutting oil and chips that might be still kind of stuck to that. And then we're gonna go ahead and set this up on an expanding mandrel so that we can skin the OD. We're just gonna true the OD up. That's all we're gonna be doing with it. Okay, so here's the mandrel that we're going to be using. This is an expanding mandrel for anybody that's not familiar with it. You have this piece here, which is the mandrel itself. And the way they got this thing machined is that it can actually compress or expand, whichever it needs to do. And these are all within a certain size range. So they come in many different sizes depending on what your bore is for the workpiece that's needed. So this one will work good for a 2-inch bore. That's what we're working on, 50 millimeter. So I'll show you what I mean. We'll take one of these guys right here and go ahead and just, this one I'll have to squeeze it just a little bit. I think the smallest size this one's made for is basically 2-inch. We're slightly under 2 inches. So just stick it into the mandrel like that. All right. This guy is tapered, so as it slides further up on the mandrel, it compresses out against the bore of your workpiece. So I usually just wipe it, make sure there's no dust or chips or anything stuck to it. Same thing with the mandrel, the sleeve. And you can stick it on there. You can see it doesn't quite go past the end of the shaft, but that's okay. We don't really need that. And the way that me and Dad's always done it is I usually just bump it, you know, on a big piece of aluminum block right here. You know, sometimes we'd have this sitting on the anvil, and then we would bump it on the anvil. But let me show you what I mean. I just got it on these wood blocks here. And usually one good hit like that is all you need to be able to hold that. Now, if you're doing a bunch of heavy turning on that, you may need to bump it a couple times, make sure it's seated really well. But we're just taking a very light cut across here to clean it up, and then cut a couple chamfers on there, and that's all we'll need to do. All right, so when we go to take it off, I'll show you how we're going to do that. But let's take this to the lathe. We'll chuck it here, run a live center in there, and just turn it. All right, so we'll chuck this in here. I'm not going to push it all the way up in there like that. It actually kind of throws it out a little bit. So we're just going to go about that far with the chuck jaw, and I have to be careful that we don't pinch down on that flat there. Just going to get it close like that. Run our center up in there. Lock our tailstock, and then let's just snug this guy up again. It should be good. Now I want to go ahead and wipe the oil off this chuck here. All right, that looks pretty good. Our turning tool, we'll use our insert tool right here. And what I like to do is, instead of turning it, we're not going to a square shoulder. Since we're not having to do that, I like to give myself a little bit of a lead angle. So I just kick it back one notch on the multi-fix right there. And we can come in here and touch off. And just make a, you know, we'll take, I don't know, maybe 20 thou or so. We just want to clean the OD up. All right, we've got her touched off there. I dialed in 20 thou. Let's see if that cleans it up. 10 thousandths per revolution feed rate, 600 RPM. It looks like we didn't quite clean it up. See the spots right there? All right, so that's some pitting in there from rust. So we need to go ahead and try to clean it up. So let's take another 10. Let's see if 10 thousandths will get that clean. So a total of 30. That, I think, got it right there. Although the finish isn't quite as nice. That's the problem when you're taking those light cuts. There's a little spot right there. I don't think that's going to matter right there. I think we're going to leave it alone right where it's at and just leave it at 30 thou. I think that'll be pretty good. So I'm just going to take this tool out, and I've got a MCHNN tool that I use for chamfers. Uses a CNMG insert. Just want to break the edge. Get it to where it looks like it kind of matches both sides. I'm not measuring the depth, but that looks pretty good right there. And I think to finish that out, since we got a little bit of rubbing from our tool and our material, the chips, I'm going to take a piece of, I think I got some 220 right here. Got some 220. Let's give her a polish. Just kind of smooth that OD up. Get rid of any marks from the chips. I ain't worried about this. I'm going to clean that up. I'm not going to run the carriage over that. But that feels pretty good. Nice and smooth to the hand. And for the guys that are worried about this right here, this is all I do. I take it and I wipe it off. Okay? Wipe it off. And then we can load it up and do it all again. Let's go get this guy off and bump another one on. Keep it going. So to get the expanding mandrel out of our workpiece, we're going to use the arbor press here. Now typically whenever the arbor is sticking out past the mandrel, you can simply just bump the end of that on a piece of aluminum or a block of wood or something, and it'll break it loose. But since it's up inside there, we need to come here to the press. Just going to put a piece in there to push on the arbor itself. And then keep your hand on it, because when it pops loose, it's going to fall. Doesn't take much. I'll tell you what, let's get that up. So that's one of the easiest ways to get your expanding mandrel apart and get it out of your workpiece there. Sometimes, depending on how tight the arbor is, you can simply just use the weight of the ram here down on it to knock it loose. Let's see if we can do that. Bring it down till it touches. Yep, see that? Just give it a little hammer. Knocked it right on out of there. So we've got all three of our rollers now bored, turned, chamfered, faced off as well. Last step is to go ahead and broach the keyway. So this is our keyway bushing right here, what I call a broach plug. That's just what Dad and I always called them, as a broach plug. And that's what this does, this is for the guys that aren't aware of this. We have our broach. This is a push broach. So you use a press to press it through. And the bushing here, or the broach plug, is what guides the cutter. So these slots are accurately milled inside here to fit the cutter. You have a couple thousandths clearance so that it can slide down through there. And what this is a progressive cut. So if you look at the first tooth right here, it just starts to engage the workpiece there, and it progressively cuts more with each tooth. Now it's about the same amount of cut per tooth, but as it goes through there, you can see that it gets deeper and deeper. So when you get to this last one, I think this one is more of a wiper, these last two. But it cuts a little deeper each time. So you press it through, press it all the way through there. Then you have to take one of your shims. You put your shim in there, and then you start it over again. Press it down in there and let it go all the way through. And you can see with the shim, it gets a little deeper each time. All right, so we'll make 3 passes with this, and I'll measure it and verify it's right. So first pass is always just the broach, and then the passes that you take in addition to that is going to be however many shims that it calls for. In our case, we got 2 shims here, so we're going to make a total of 3 passes to cut our internal keyway. So we're going to use the old electric press. That one's a broaching machine. We'll go get it set up, and we'll get our keyways broached. This is my electric press that we're going to be using to broach the keyways. I've showed this in past videos. A lot of you guys really love this old press. It was made by Kent Moore. And my dad, this press was given to my dad sometime in the early 70s. I couldn't tell you when exactly. But it was pulled from a scrapyard. And a friend of my dad, Mr. Rozicki, who was a welder, pulled it out of the scrapyard and brought it to my dad and said, "Here's a press for you. I think you might like it." And the only thing that Dad ended up doing was adding this 3-phase electric motor to it and the pulleys on the back, and making it automatic instead of a hand crank. It was originally had a hand crank on the back, and I just noted it as a hand crank, a crankshaft press, I'm sorry. But with the addition of the 3-phase motor and this Dayton switch right here, a reversing switch, you have forward and reverse. You can just simply go forward and reverse by flipping this here. I'll show you. So that's pressing, and then you go in reverse to retract. And it's always worked excellent. This is a broaching machine right here, and also used to press shafts out of bearings and things like that. So it's been a very, very handy machine over the years that I couldn't tell you how many keyways we've broached over the years in this machine, but it's done quite a few. And it's getting ready to do 3 more, but I just wanted to highlight the press that we're going to be using. I know you guys like watching this. So we have our press plate down there that we're going to use to set our workpiece in like that. That'll support the whole bottom of it pretty well, you know, across the back. And then one other thing I was going to point out, typically whenever you go to set your broach in here like I'm doing now, we're going to just set it in there and it'll catch that first tooth. And a lot of times you need to just kind of bump it in there to kind of get it started on that first tooth. I like to use a copper or a soft blow. Just never use like a ball peen, because you know, this is tool steel, it's hardened tool steel, and you don't want to chip it. So just always use a soft blow hammer or a lead hammer, nylon, something like that when you're bumping these keyway broaches. I'm going to go get my cutting oil, keep this thing nice and lubricated, and we'll go ahead and start our broaching. All right, let's start cutting the keyway. By the way, I like using my earplugs over on this machine because it is clackety and it's really loud. All right, and then we got us some cutting oil. Do need to keep this thing lubricated, especially if you're cutting steel materials like that. Keep it oiled. All right, here we go. Now to start with, I'll press it and then I back off so that we can let the broach naturally center itself up. Go about 2 teeth, back off, you'll see it move a little bit. Go a couple more teeth, back off. Now it should be nice and straight. Now, what we'll have to do is back up and finish pressing it with a piece of material like this, like a pin. Get it in the middle of the broach. Go ahead and reverse it. Pull the pin. Pull the broach plug out. There, as you can see, your wiper chip there at the end. And we're just going to go up until our cutter will clear the ram. Just like that. There's our first pass. Now we'll grab a shim and put that in there and keep it going. You been filming that?
Yeah, it was terrible video by me.
All right, we got a shim. What I like to do is just kind of put that in there. I like to hold it with my finger and then put the broach in like that and pull down on it, and it'll go down to that first tooth and stop. And then we just repeat the process. I back off several times at the beginning just to make sure that the cutter is straight and it's not being pushed to the side and dig it in. Back off, let it straighten itself up, and then let it go. Keep it lubricated. I like to pull the shim out, otherwise it vibrates and falls out into the box there. All right, so now we got our second shim. You're just going to stack them, and then I usually knock the chips out of this if there's any left in there. Just kind of knock those out. All right, put the shims in, just hold them in place so they don't fall out on you. Come at an angle, and then this is where sometimes you got to use the hammer to kind of knock it down in there, but it's already started, so I won't worry about it because we really don't have room anyway. All right, so it should be good. Let's go ahead and get some more cutting oil on it. Don't be afraid, use a bunch of oil. I got a 55-gallon drum of that stuff, and I use it. All I'm doing is making sure that it's not going to dig into the broach plug and it's centered on the cutter there. Put your hand under there to hold it so it doesn't fall down to the floor. Nice looking chip right there. All right, so at this point I just need to get a rule and measure my depth there and make sure that we're at least matching the same depth as the sample piece that we're measuring to copy. All right, so our sample measures 5.5 millimeters deep. I'm going to go ahead and pull this guy out. And let me do a measurement here and see. So that one is 5 millimeters deep. It's 5 millimeter deep on that one. So I'm just trying to decide if I go with another shim, it's probably going to cut it too deep, but we may end up having to do that. Probably need to go ahead and make one more pass in that since we're 0.5 millimeter off. I did not measure the keyway height on that shaft. I mean, it's only a 1/2 millimeter. It's got to clear it. Let me do some thinking on that. The depth of the key is a 1/2 millimeter shallower than the sample. I'm going to give Joe a call and ask him if he'll go measure the stick out of the keyway that's on the shaft and see if we've got clearance where this guy is cut right now. I think it's going to be good where it's at, and I don't want to have to run the cutter through there again. All of my shims are standard thickness there. All we need is one about 20 thousandths thick, but I don't have one. So I'm going to go ahead and move on to the second one while he's verifying that information, and we'll go ahead and get moving on that one, at least get the bulk of it cut out. If we have to come back and make another pass, we can certainly do that. It's an old beast. Sometimes it's a little particular. Like that. See? All right, guys. Well, this is going to wrap up the machining. So I talked to Joe, and he went ahead and got a measurement on the shafts that are on the roller machine. I asked him to just measure how far that keyway is sticking out. And according to his measurements, he measured 4.7 millimeter. So our keyways are cut 5 millimeters deep. So technically, if his measurement's correct, this should just slide on there. And if for some reason he goes to put them on, they're too tight, we've got our plug, our broach, and I will just either grab another shim or we'll just make a thin shim out of a piece of shim stock and make another pass down through here and try to cut it a few thou deeper. But I was looking for one of the shop made shims because we have made some out of shim stock or sheet metal, and the ones that I found were either the next size up bigger, like too wide, or the small ones. So I didn't have one readily available, and it was going to take some time to find some shim stock and get one made up. So I'll just cross that bridge if that's what we need to do. But I feel good that these guys are going to be ready to go and put on the machine. So for those that are not familiar with a roller machine, it's going to be a configuration like this. You're going to have 2 rollers here, and you're going to have another roller, sitting right here. And the material passes down through here, and when it comes down between 2 of the rollers, it hits the 3rd roller, and it makes it bend up, which in turn creates an arc in the materials that you're trying to roll through there. All right, that's how that works. And Joe did say that we could get some video of him actually using it and doing this material that he's got to roll. So hopefully I'll have that and have dropped into the video here so you guys can see how this is going to be used, how the roller machine is going to be used, and the material that he's actually rolling into an arc that he's got to do some fabricating on. So other than that, this video is finished up. I always try to bring you guys some helpful tips and tricks and tools of the trade that we use here in the shop. Our expanding mandrel, using a hand ground high speed steel tool bit in our boring bar, using a broach, how that's used. So I just try to always help you guys out as much as I can as we're getting the machine work and the projects done. And I hope that you guys enjoyed that, and I hope you guys come back for the next project. We'll see you then.
Yeah.
Did it fit?
Like a champ.
Like it was made for it, right?
Made for it.
All right, let's see you put one on. Yeah. He said this one right there, he's kind of boogered the key up. You got to do a little filing on it. That's all that one is. But it looks like they're going to work.
They're going to work perfect.
Threads are going to be a little short, but you said you're going to put your disc out here.
I'll put a big washer and then that keeper nut on it.
Okay.
Yeah, see, I boogered that up. That's when I tried to get out, and it just won't come out.
That's all right. A little bit of file work, but we know they fit, so they worked out good. Look at that, like it was made for it. We'll get a video whenever he's rolling the tubing through here, so we can see how he's actually going to put this machine to work. What is this? What brand? Carroll?
Carroll.
Okay.
And I actually picked it up right there in Loxley. Went and got it the same day.
Brand new?
Yeah.
Oh, okay.
Yeah. Well, yeah, went to pick. I needed it. Called Jed Jones. And whenever I loaded it back in the truck and drove it back same day.
Dang, okay.
We had to have it stopped.
There's a bunch of the other dies. He's got all kind of different dies for this, but obviously this one's
What's up, Isaiah?
custom. He didn't have what he needed for this, so we're just
doing,
going to make it work for the job.